Dear students, welcome back to my YouTube channel MCBChemTube. And today I'm going to discuss with you Beckmann rearrangement from the topic molecular rearrangement transformation. Beckmann rearrangement named after Ernst Otto Beckmann, and it is closely related rearrangement in which the carbon migrates from the carbon to the nitrogen, electron deficient nitrogen. And it is an acid mediated isomerization of oxime to amides, and it is shown here, and you can see that this oxime and R1 and 2 is bonded to a carbon double bond N OH, and in the presence of acid it gives amide. And you can see that here in the presence of acid, there is a rearrangement like this, a migration of one of its alkyl group to the nitrogen take place, and this hydroxyl group leave as an hydronium ion, and an amide, a product, final product amide is obtained. And the acids used are concentrated sulfuric acid or formic acid and phosphorus pentachloride and the boron trifluoride, thionyl chloride and tosyl chloride. And these reagents can be used as an acid or instead of acid. And R can be alkyl, aryl or hydrogen. Coming to the mechanism of this rearrangement, and we are starting with the oxime, and in the presence of an acid, what happens is this hydroxyl group get protonated and it reacts with this protic acid and it form an hydronium, and you can see it is this hydronium, and this is a good leaving group and it leave, and this is followed by an migration of one of its alkyl group. Usually the group trans to the leaving group will migrate, and here you can see that a hydroxyl group is in this direction, so the opposite group is this R1, and R1 get migrated to electron deficient atom. So what product you get then? And you get this product R2 single bond carbon and double bond nitrogen, and R1 is migrated to this nitrogen, and R contains a lone pair of electron and it can form a nitrilium and a triple bonded nitrilium ion, and this carbon is electrophilic because there is an electron deficient nitrogen here. A nucleophile can attack this carbon, so here you can see that the hydroxyl nucleophile attack this carbon and triple bond will cleave and it form a compound like this, right? And R2C double bond N R1 it is here, and the water attacks this carbon atom and will form a bond, and this is a hydronium, and this here from here a proton will leave from here minus H plus, you can see that, and form a combo like this. Then this can undergo tautomerism, like ketone tautomerism, and this is imine, and it form a product amide. It is here. So you are starting with oxime and you ended with the product amide. And in this reaction, you can see that the R1, one of its group, alkyl or aryl group, migrated to the nitrogen, and F double bonded carbon is formed here, C double bond. Okay, in Beckmann, if you are using BF3, boron trifluoride, the leaving group will be like this. This hydroxyl group react with BF3 and form an better leaving group like this. And if you are using, instead of protic acid, tosyl chloride, and this OH become ODS. This is a good leaving group and it undergo rearrangement like this. And if you are using phosphorus pentachloride, you get a phosphate uh, chloride leaving group like this. So these are the different leaving group. And next one is R1, R2 can be alkyl or aryl or hydrogen. In this example, I'm giving one example, acetophenone undergo Beckmann rearrangement and it form acetanilide. So what are the changes that occurs here? And you can see that this phenyl group is migrated because this is anti to the hydroxyl group or trans to the hydroxyl group. This group get migrated to this nitrogen and that is here. And here C double bond O is formed. You can see that MEC double bond O and it is forming a product like this N form a bond with phenyl. This is acetanilide, right? And next one of its important application of Beckmann rearrangement is you can use it for synthesis of caprolactam. This is industrially important, and which caprolactam is prepared by Beckmann rearrangement of an oxime, and this is the oxime. This oxime is prepared from cyclohexanone. Cyclohexanone, that is a cyclohexanone with hydroxylamine. You get an oxime like this, and it undergo Beckmann rearrangement. It form ring expansion, and this caprolactam is very important industrially, which is used for the manufacture of nylon. By heating caprolactam, you get a nylon. Okay, and in this oxime, in the presence of acid, it forms caprolactam. So let us see what is the mechanism of that. So you're starting with this oxime in the presence of sulfuric acid, like in previous case, it become hydronium. Hydronium is a very good leaving group. The next one is the migration, alkyl migration, as water leaves, and it form a cyclic structure like this, and this carbon migrates to this nitrogen and C double bond. You can see it here, and a ring expansion take place, and this is electrophilic center. Water attack here, and it form a hydroxy compound like this. Then it undergo a tautomerism to form caprolactam. Okay, it is shown here in each case. So, which group migrate in Beckmann? Already I told you when there are, if you are using geometrical isomers like this. So in this case, you can see that this is 1, 2, 3 propyl group is anti to this hydroxyl or trans to this hydroxyl group. And in this particular case is another isomer of this compound, and the methyl group is trans to the hydroxyl group. And if you are using such mixtures, which is obtained from this ketone in the presence of hydroxylamine and oxylamine, the ratio of this product is 75 and 25. So this geometrical isomer in the presence of Lewis acid, that is Beckmann, what happens is the group here in this particular case, this propyl group migrate to this nitrogen. So this propyl is attached to an NH that you can see it here, and it form a ketone like this Me. And the ratio is exactly same as the starter material, that is 75 or is very similar, 73 is obtained. And at the same time, there is another product where from this geometrical isomer, that is methyl is migrated here. You can see the methyl is attached to the NH. and the ratio, the group that migrates should be that trans to the OH in stoichiometry. And the ratio of products are almost same as ratio of geometrical isomer. And another example, you can see it here. This is an oxime formation, and in this first case, you can see that isopropyl is trans to this hydroxyl, and methyl is trans to this hydroxyl in second geometrical isomer. And the ratio of these stoichiometrics are 86 in is to 40. And in the presence of aluminum oxide, Beckmann and Beckmann rearrangement and keep the product like this. And in first case, the isopropyl group is migrated, and second case, methyl is migrated, and the ratio of 88 raised to 12. And another example, this is R group is both phenyl, and in this particular case, you can see that in the presence of acid, it forms a hydronium ion is a good leaving group, and this phenyl group migrate, and it form nitrilium ion and water nucleophile attack, and it form a product like this, and finally it tautomerize to give corresponding amide. And second example, in this particular case, if you are starting with this material, this hydroxylamine, in the presence of polyphosphoric acid, this is the reagent here used, and you can see that this carbon is migrated to this nitrogen. That is why you are getting this nitrogen here. And this carbon, it is forming double bond O here. Okay. And if here the hydroxyl group, it is the alkyl group opposite to this hydroxyl group get migrated. But whereas in second case, and this is another isomer, this carbon is migrating. The trans alkyl group is migrating here. Okay. And third example, and if you come up with a problem like this, and here hydroxyl group is not specified which isomer and which one will migrate here. If you have two different group attached to this carbon, and in the presence of acid, you can see that the migratory aptitude is like this. Hydrogen H minus have more migratory aptitude than phenyl, than higher alkyl, and that is electron rich compound than methyl. So in this particular case, this is a primary alkyl group, and this is a secondary alkyl carbon. So these secondary alkyl carbon get migrated to electron deficient atom, and you get this product oxime. And next one, in this particular case, which group will migrate? This is secondary hydrocarbon, and this one is tertiary. So tertiary hydrocarbon get migrated to electron deficient nitrogen, and it form NH here. This carbon is attached to this NH, and it form a carbonyl here. And in this particular case, only the changes are here. Oxygen will come, and the NH will be inserted here in between this. Okay. And in summary, we have learned a rearrangement reaction to electron deficient nitrogen, and it is closely related rearrangement in which the carbon migrates from the carbon to the nitrogen, and Beckmann is acid mediated isomerization of oximes into amide, and usually acids like concentrated sulfuric acid or formic acid, or PCl5BF3 or thionyl chloride, tosyl chlorides are used as a reagent, and the group trans to the OH in the stoichiometry usually migrate. And one of the important reaction application is synthesis of caprolactam from cyclohexanone is a ring expansion reaction, and which is useful for industrial manufacture of nylon. Okay, that's all. Thank you for watching.